Hello, Titans. Here's your lesson for today, Monday, August 31st, last day of August. This will be on page 8 of your notebook. We are going to continue and finish up with section 1.3. Okay, there's your homework. Moving on. Okay, so this the math itself, when we solve the equations, are going to be a review. But what we're going to do today is we're going to classify. And so the homework tonight is going to require two things. The answer, and this is how you're going to answer. It's called the solution set. This stands for all real numbers. And instead of writing those three words out, we use that symbol. When you write that symbol, it's like a double bar and then an R. Okay, an equation that is never true is going to be called the empty set or the null set. So you can either use this symbol or this symbol. Either one is fine. So this is called the empty set or the null set. That's N-U-L-L, null. And this is just a fancy way of writing an answer. This would be the same as saying y is equal to 20. It's the same thing. That's what that means. Okay, whoops, sorry about that. Okay, so we're going to go over here and we're going to classify. So these are the answers that we're going to get when we do work. And over here, the type of equation is going to be the actual word that we're going to go ahead and classify with. So the first word we need there is when you have all real numbers, you have an identity. So when it says solve and classify, you would solve. The answer would be all real numbers, and you would say identity. An equation that is never true is a contradiction. And depending if you get an answer, something like y equals 20, the last one is called conditional. Okay, so let's take a look over here. So if I just did the math here, there's nothing to do right here. There's two items, two terms. But over here, if I put 3 plus 2 together, it would say x plus 5 again. So this is an identity, an equation that is true for all replacement values. So no matter what x you pick, I'll just for fun say x is equal to 10. If x is equal to 10, this would say 10 plus 5 is equal to 10 plus 5. That's an identity. Any number I pick, okay, maybe instead of 10, I choose 20. If x is 20, this would be 20 plus 5 is equal to 20 plus 5. 25 equals 25. So there isn't just one answer. There's a multitude of answers. So that's why it's called an identity. Oops, sorry about that. There we go. And your answer to me is this letter R, or you can write out all real numbers. Every single number, even fractions, decimals, any kind of number will work, okay? A contradiction is an equation that is never true. So if you want to choose a number for n here, say 10 is, and I'm just making up 10 because I feel like it, is 10 equal to, plug it in again, 10 plus 1? That's never true, right? That is never true. And so that's why this is a contradiction. It contradicts itself. And the answer is one of these symbols, either this symbol or this symbol. I don't care which one it is. Or you can write the word out, empty set or null set. And then conditional is an equation that is sometimes true and sometimes false. It all depends on the replacement value. So if we, not just me, if we did this work, we would subtract 5 to both sides, right? So 2y is equal to 40. If you divide by 2 on both sides, y would be equal to 20. Here's the answer. your book likes to write it like that. But here's your answer. Y is equal to 20. And that would be a conditional. So long as you use y is equal to 20, this original equation has an answer. Okay, so today we're going to be doing two things. We're going to be solving, and we're going to either use all real numbers, empty set, or a plain regular answer like y equals 20. And we're going to use these words, identity, contradiction, and conditional. So if you want to get started on the next problem, it looks like we need to do, it says solve it, then classify it. So it looks like we need to do a little distribute. I would hit pause here and get going after we start this first one. Okay. Oops, Miss Hartover. Touchy little thing here. Okay. So remember, we want two pieces on each side, so we need to combine like terms. How much is, this side is fine. 7x's minus 5x's is 2x's plus 7. Okay, so you can see right here that this is going to be an identity. 2 times what number plus 7 would be equal to 2 times what number plus 7. So right here, you can stop your work if you notice that if the left side and the right side are exactly the same. Only if they're exactly the same. So we already know right now that this would be an identity, okay? It's like example 1 on the chart above in your notes. If you continued, I want to show you what the math is because that's important for later on. So if you continued, you would normally pop this 7 over and subtract 7. And that's 0, right? Both sides of this is 0, right? And you can see again, they're totally true no matter what x you pick. And then if you were to divide, oh, sorry, we're not ready to divide. We have to get the numbers on one side and the x's on the other. So I'm going to pop the 2x over. And 2x's minus 2x's is 0. 2x's minus 2x's is 0. And 0 equals 0 is a totally true statement. If you come up with a funny problem during a quiz or a test, and you get down to this, 0 equals 0, totally true, that again is another indicator that this original problem is an identity problem. So here's your final answer. The answer is all real numbers, identity. You need two parts. Solve it. Any number will work, so R for all real numbers, that's the solving part up here. And then to classify it, this is an identity. Now, why is it that we went ahead and just didn't notice that right here? Could I have stopped Ms. Hartover right here and come to my answer? Yes, if everything totally matches equally. But this process of moving things down and 7 minus 7 is 0. 7 minus 7 is 0. 2x minus 2x is 0. That process is going to be important for chapter 2. So you could have stopped here. Just know that if you end up with a 0 equals 0 totally true, that your final answer rests in the land of all real numbers and identity. Okay, I would like you to hit pause here. Start this next problem. Okay, so you should have collected like terms right here after you did the distribute. So a -6 plus 4 is a -2. So on this problem, it does not match like this one did here, right? So we're going to keep going. So I'm going to pop that number over. I'm going to add 5 to both sides. So 3x would be equal to 3x. And then a 5 minus 2 is a 3. Then I'm going to keep going because remember I want the x's ending up on this side, right? So I'm going to, if I pop the number over to the right, I'm going to pop the letter over to the left, so minus 3x. And then 3x's minus 3x's, that would be 0. Don't say 1x because that's not true. 3x minus 2x would be 1x. But 3x's minus 3x's, that cancels to 0. I'm going to bring this number down. Is 0 equal to 3? No, that's totally false. That's not true. So that's one indicator right there that you have a contradiction. So your final answer for this problem is going to be the empty set with the word contradiction. That's when you get a false statement. Then you can use the empty set, or you can say no solution. So the empty set means there is no number that would work. And this original problem up here, this side can never be equal to the other side. It contradicts itself. Okay, and then obviously we're going to move on to the next one. So if we've covered all real numbers, identity, empty set with contradiction, what do you think this one's going to be? There was 3 examples in that chart above. So, okay, so moving on. For this one, I want my x's on the left, so I need to pop this number over. That's a positive 3. So I need to minus 3 to both sides. 3 minus 3 is 0. Be careful, this is what we call an embedded negative. Don't drop the negative, it's hooked to the 8. And 5 minus 3 is 2, and bring down the negative 7x. Keep going. Move the number to the right. We're going to move the letters to the left. So we're going to add 7x. And again, you could use a calculator here. You would enter negative 8 plus 7, enter on the calculator to get the proper answer of a negative 1x. This one cancels. And this is just a bit of review. What do you do? When you have a negative 1x, you need to divide by a negative 1. This cancels. And a 2 divided by a negative 1, x would equal negative 2. And so what's our final answer? Because today's a little bit different. So our answer is not all real numbers. Our answer is not empty set. Our answer is yes, there's a number that works. It's x equals negative 2. And so long as, or you have the condition of, I don't know what keeps making that. Sorry. Oh, uh-oh. There we go. So long as you use number 2, x equals negative 2, pen errors, then this is a conditional example. Okay, you have homework to do. You're going to have examples of all of these on the homework. Make sure that you end up with 2 items for every final answer. Okay, so all real numbers for identity. The answer is the empty set if you have a contradiction. And you have the word conditional if you have just a regular problem. Oh, there we go. So this is tonight's homework. So it's on page 27, 84 to 87. Please title that at the top of your paper. And remember, there's 2 things for work solve, where you get 1 answer, all real number answer, no solution answer, and classify as identity, contradiction, or conditional. Okay, so these 4 problems. Thank you very much.